Hi, thank you, and for the people who are watching, and if you have any questions, please do so, and once we give you your challenge, please post them back, and
wait, do you want to tell them who you are?
I am Simon.
Look, we've got 2 people watching already. You want to say hi?
Hi.
To who? RJ
and Sherry, Joshua, and Anna.
Yeah, we've got lots of people watching already. So how come we started Simon the Scientist?
Because usually when scientists explain things to kids, they don't really understand. And so I do it in a way in either nature or in what us humans do or what things are like.
Yeah.
Not in like very complicating way.
Yeah, we break it down into ways where kids can teach kids. And I think we have a couple special shout outs today as well, because we got a very cool video from our friends Connor and Logan yesterday, who were inspired to do some science of their own. And we also have a very good friend all the way from Moose Jaw watching this morning.
Hi, thank you, Camille Wilson.
And we also are saying hi to Vince and Parker. You see that? We've got Peyton and Jackson from Snow Lake.
And Amber.
Yeah, Amber's watching too. Pretty good. So Simon, everyone, I'm Jacqueline. I'm Simon's mom. And I'm going to turn the phone around here so Simon can get started with his topic of the day.
So what I am doing is I am soon going to be showing you physical changes and chemical changes. Examples of physical changes: crumpling paper or ripping.
Well, here you go. Why don't you show what a physical change is? Wait. Before the examples, can you tell us what is a physical change?
A physical change is either when something changes shape, or if it becomes something new, but it's still the same material or object.
Yeah. At what level?
At an atomic level?
Yeah, you're right. At an atomic level, it's still the same.
Here's an example of a physical change.
Oh, the paper is very different now.
Here's another example.
Oh, wow. How are those physical changes?
It's still the same piece of paper, but it just looks very different.
Yeah, you're right. What else is a physical change with paper? Oh, well, wait. Maybe we should do it over a bowl. Just rip off a little piece. Yeah, good.
See, look.
Yes, I see, Ella.
This paper knows how to swim.
That paper does know how to swim. So now it's really different. Tell me what the paper is like now.
I can see little specks of the paper.
Yeah.
And it looks much lighter than before.
Yeah. So it's changed. Can you pick it up and show us?
And it feels very wet. It
Yeah.
feels like paper cloth.
Interesting. So is this a physical change or a chemical change?
Physical?
Still a physical change, because at an atomic level, this is still
Paper.
Yeah, you got it. So you've got a pretty cool book back there. Now that we understand what physical changes are, you've got a book back there. What's that all about? Oh, wait.
It's about chemicals and elements of the periodic table.
Yeah. So before we get to that book, we have Parker, who noticed that the paper is now soggy, but it's still paper. And we also have a shout out to M, who's watching as well. He's our good friend in Treehern.
Paper.
Yeah, still paper. Can you show us something in your book?
Yeah.
Why do you like that book, Simon?
Because it shows all the elements and what elements and what all the elements can do.
Yeah.
And here's one of my favorite. I honestly don't know the answer to the question yet, but
Okay, where's the question? Show me which one.
right here. When hydrogen and sulfur and oxygen combine, they form a compound called sulfuric acid, an acid so strong it can dissolve rock. But since it has sulfur in it, it's the smelliest element, does that make the acid stinky?
Oh, I wonder if we have any chemists out there who could answer that. So the
Maybe
question
I could
is...
just part into hydrogen and oxygen.
You just want to fart into it?
Yeah.
I wonder if that would work. So if we have anyone who can answer that question, is sulfuric acid stinky because it has sulfur in it? And could Simon just add his fart? Good question. All right, so that's one of Simon's very favorite books that he likes to read. We'll put that to the side because now we're going to talk about what a chemical change is. So what's that?
When something changes entirely, like it's not that same thing that it was before.
That's right. It's not that same thing that
An
it was
example
before.
is burning a piece of paper or maybe exploding it.
Yeah.
And both of those will, wait, no, exploding it maybe won't. Because maybe some of the papers are, maybe it will just scatter the paper, but the paper is still the normal paper.
Oh, so it could do both. It could scatter some pieces and it could cause some pieces to burn. Yeah. So we have another hello here. We have a big hi from M, who's loving this, our friend in Treeherne. And we also have a good morning from Marion Pearson, who's all the way in Cranberry Portage, who's known you since you were a little baby.
Okay.
Yeah, pretty cool, hey? Okay, so we have an example of some chemical changes, and that means that the elements change on an
Atomic level.
That's right. The atoms change. They become something completely different. And you have some chemistry that you're going to do for us. What are you going to make today?
Elephant toothpaste.
Yes, elephant toothpaste. Before you do, we have some more hellos from Jackson.
Does that also mean I'm going to have to do it on an elephant's toothbrush?
Well, do we have an elephant to try it out on?
I'll go get the toothbrush, and then we can go find one.
I have no idea where Simon's going. I asked him if we have an elephant to brush their teeth, and he's going to find something, so I'm not too sure. While we're waiting for him, one of our ingredients is hot water, something that I couldn't do ahead of time. So while Simon has disappeared, I'm going to get the hot water ready.
I have the toothbrush.
Oh, there you are. You went to get that toothbrush for elephant's toothpaste. Okay, Simon, you can get on your safety equipment. Oh wait, we were in the middle of saying a hello to, we were saying hello to Jackson and Sloan. And also, guess who else is watching, Simon? Your cousins from Ericsdale. Lucy and Edward, Elisa, everyone there is watching as well. Okay, we are back. Oh, and thanks, Camille. I actually showered today. It's day 11 for us of isolation, so showering doesn't happen every day. Okay, so what are you putting on?
Gloves and safety goggles.
Yeah, how come?
Because we're using chemicals.
Yeah, that's
It
right.
can be poisonous or dangerous.
What's a word we like to use for something that's poisonous or dangerous to our body?
Acidic.
Oh, no, that's a different type that could be dangerous. Do you remember what? We talked about it a few days ago.
Alkaline or base.
Well, those are pH levels. We talked about toxins, things that are toxic to our body, and chemicals can be toxic to our body. So how come you have goggles on when you have glasses?
Because the glasses don't fully cover my eyes.
That's right. Glasses are not protective eyewear. Goggles are. And what about your gloves?
They're okay.
Yeah, they're good. Oh, you're gonna not wear your glasses for this? You're still okay with no glasses?
Yeah, just things look a little smaller.
Okay. Ooh, Connor guessed toxic. That was the word as well. And Sherry says that you sure look like a professional. Okay, so let's get started. First of all, we are going to bring your pan and your bowl. Here, we'll move some of this stuff out of the way.
Get out of your stuff I don't need.
And we also have a cup here. So we'll do the cup first. So the first thing we're going to do is get your scissors and yeast. Okay, so you are going to need to cut open the top of that yeast and pour it into the cup, but be very careful not to spill any.
But not like spill none.
Yeah, try not to spill any. So cut it over top in case some falls out. Don't put the paper in there. That's okay, no big deal.
Get that paper out.
Yeah, it's tricky to cut these packages of yeast sometimes. Whoa, you got some more paper in the cup.
And I think this is going to be...
Okay. Let's see if that yeast will come out yet. Oh, yeah, you can see it pouring out. Ooh, Matthias has said hi.
Matthias?
Yeah, Matthias.
Are we all friends?
Yes, he is your friend.
I want to see him.
Yeah, we haven't seen him in a little while.
I think I've never seen him since kindergarten.
Since kindergarten. I think we've seen him since then.
Well, since like near the start of grade 1.
Oh, maybe. So what that means is Simon would like to see you again soon, Matthias. Oh, and big hi to Auntie Wendy too, who's watching as well. Okay. And in this, we are now using our hot water. And where did that spoon go?
Spoon?
Yeah, we had a big spoon here somewhere. Can you run and grab me a big spoon, please?
Spoon! I got the spoon!
Go quickly, please, sweetie.
Can you please be quiet? Naughty babies! Naughty! Sorry, that's just my sister's baby.
Yeah, you might be hearing Sister Ella here. She's here today with us too, and she has a baby that she's playing with, and she has named her baby Parker. So you know, Parker, you're not confused. Ella's playing with her baby that she named after you. Okay, so we need 4 spoonfuls of hot water.
And this is to activate these.
Yes, that's right.
1, 2, 3.
Okay, mix it up, and if it's still chunky, we'll add some more water.
Still kind of chunky.
Yeah. Do you smell anything, Simon?
Ew.
You don't like that smell?
No, I don't know.
Do you know what that smells like?
What?
It's yeast, so it smells like freshly baking bread. Oh, okay. Okay, let's see. You keep spinning. Oh, yeah, it's still kind of chunky. We don't want it chunky. Hang on. Can you hold this over the yeast while... All right, so where'd that spoon go? Here we go. I'm going to add a little bit more water and see if we can get those
It
chunks
kind of
out.
looks like chocolate ice cream.
It kind of does, but I bet it doesn't taste like chocolate ice cream.
Of course, it's yeast.
Okay, watch the phone so you can watch where you're pointing the phone so people can see. Oh, yeah, it has to be like that, this way.
Yeah.
But point it where we're working, okay?
No. You can hold it now.
No, I'm still stirring.
Is it
Okay,
liquidy
that
enough?
should be good. I think that's liquidy enough. Now, we have this mixture of yeast and water. This is actually called a solution.
And here comes a joke that I would like to tell you.
Okay.
The joke is, why are chemists so good at solving problems?
Why?
Because they always have good solutions.
Nice one, nice one. All right, so here we're going to add in our chemical. And because I don't want anybody trying this at home, I am not even going to show you the chemical we're using. You just have to trust me that that this is going to work. Okay? So, Simon, can you hold the phone again? And you can point the phone at the bowl and the dish.
But that's basically impossible.
Well, you can try. And I'm going to put the chemical, the carefully measured chemical, into this water bottle. That's going to be our vessel here. Here we go. And
Elisa
I'm wearing
said-
gloves as well.
Elisa said, "I like that bowl." Yum.
Oh yeah, it's a good M&M bowl. Okay, so do you remember next what we add into this, Simon? We need to add a squirt of dish soap
Squirt of the soap into where?
into the bottle.
Why dish soap?
That's our recipe, or I should say our formula. Just one squirt, that's enough. And we can add some food coloring. Now the food coloring we can really use any color, but if you want it to look like toothpaste, we need red and blue, because there's some toothpaste that has those red and blue stripes. And Simon, would you like to put them against the wall of the bottle? So you have to drop blue right against the wall of the bottle.
Red against the wall. Of
Blue against one side, red against the other. So push it right up against the side there. Oh, I can't quite see what you're doing. Good, that's the way. And then do red on the opposite side. I'm gonna come around here.
Can we do all colors?
Well, maybe next time, but right now we want to try to make it look like toothpaste.
Maybe I'll look.
There we go. All right, so now let's see if we can create a chemical reaction. So you can pour in the yeast and let's see what happens.
3,
Sit there, Parker, with what you done now.
1, and let's go.
Pour it in quick.
Do not knock this book down.
Pour it in quick.
5 minutes.
Some of our yeast spilled out.
Nope. It's not.
Well, it's
great.
not doing a fast job. It is reacting, but sometimes this happens.
Maybe not enough yeast.
Maybe not. So what we're going to do is we're going to try this a second time here. So let's take this guy out. You can see that it is reacting,
Parker, do you
and we can also feel heat because this is an exothermic reaction,
see?
but it didn't react the way it was supposed to. So Simon, I'm going to set this up real quickly again. Can you hold this?
Do you see any? Do you see any?
And I'm going to be really fast here.
Do you
So
see
hold
the
it
blue
towards
part?
the
Do you see
bowl.
blue part?
And let's go real quick here.
Elisa said, "Good one, Simon." Lol.
Yeah, for your joke. Why don't we ask our friends if they want to tell us any science jokes while we're waiting for me to try this.
Camille also said Simon is doing a great job.
Oh, I agree. You are doing a great job.
Michelle, I think, said learning has never been so cute.
Well, I would agree with that as well. You're pretty cute, aren't you? Okay, we're going to try this one more time. Guess what happened to me doing this experiment or this demonstration a couple months ago? It just didn't work. So we have kids in Cranberry Portage Elementary in northern Manitoba, and I went there and we had an elephant toothpaste extravaganza trying to figure out what's working and what's not working. And they figured out that there's a lot of variables that make this work or not work. Isn't that neat? So are you watching? Put the phone on here. So I'm putting in the stripes again. I've mixed the yeast. We're adding the dish soap. And if this doesn't work a second time, well, we're gonna keep trying and we'll post it on Facebook soon. But sometimes there's variables that we're not aware of. Okay, ready? Let's try again. 1, 2, 3, go.
Elisa said, "Why is it called elephant toothpaste?"
Well, it's starting to react again, but again, it's not doing what it's supposed to be
Elisa
doing.
to add.
It's big enough to fit elephants. That's good. Okay, so again, it's reacting, but not as fast as it should be. So what I'm going to do is change up a couple things here. I'm going to change the chemical that we're using, the bottle.
Sit in your pocket. Do not move. You get your teeth to come on.
I'm going to grab another bottle real fast. And we're going to try this again.
That's it.
17?
That's it.
What's that type of dish soap, Simon?
Now you
Um,
Papa.
Dawn.
You too.
Okay.
I'm gonna hold
So
it
you
like
can see it's starting to react, but usually it's really, really fast. And that's an important thing to know about science, is that sometimes there's variables that we just don't know about, and we just have to keep trying. Simon's really good at that.
Logan says he likes his science videos. Okay.
He likes it?
Yeah.
Good, I hope so. I like it too. So Simon, why don't you tell some more jokes so that everyone's not just waiting for me?
Nicole said our thought is maybe the yeast is expired.
Well, I did check that, and it doesn't expire until May of this year.
Oh, Aston said hi, Simon and Nola from Sawyer and Nova.
So that's a great variable that we've had to test in the past, and this yeast is not expired yet. Good thought, though, because sometimes that can happen as well.
Great thought, though. That's a good way of thinking, Nicole.
Okay, so I'm going to go here by the sink to get hot water.
Maybe it's not the right type of yeast.
Well, this is, but there's something going on with it, that's for sure. Simon, would you like to tell some more jokes?
Camille Wilson also said, is the water hot enough?
Well, that could be a factor too.
Vincent said he has a science joke. Can we hear it?
Who does?
Vincent.
Yes, let's hear it. That's Parker, Simon.
Okay. Good one, Sherry. Good one. My sister's here.
Okay, Simon, are you getting any jokes?
Wait.
coming in?
Oh yeah. Sherry Clark said, why did the scientists cross the road? Because he didn't want to get blown up by a science experiment. And Vincent said, what do you call an acid with attitude?
What?
I don't know the answer yet.
Okay, I think we're ready to try again.
Kevin, amino acid.
I get it.
Oh yeah.
That's awesome. So look at this, Simon. Can you
Good
show this
one.
bottle? This bottle is starting to react. You can see it. Wait, Simon, just show this bottle, please. You can see that it's reacting and it's causing this foam to grow, but usually it's really, really fast,
And
not
here's some-
slow.
And here's a strange thing. If that one had been made later than this one, then why is this one shorter? Why is this one shorter? It was made before.
Okay, so this is going to be our last try. If it doesn't work, we're going to keep trying and we're going to post it for you later today. But we're also doing our second session on Instagram shortly, so we will try there some more as well. Are we
Hydrate.
ready?
Yeah.
Here we go. 1, 2, 3.
Hydrate, lean.
Nope, something's going on today where it's not working. You know right away if it's working or not. Can I see the camera there, sweetie?
Maybe the first one had too much yeast.
Well, this is the same recipe we always use, but some kind of factor is affecting this.
I've heard it.
Oh, we have another suggestion here. Maybe the first one didn't have as much. Interesting. So what I'm going to ask everyone to do is watch our second session here on Instagram, and we're going to keep it going, but we're going to make sure that we get this going and we're going to post it on Facebook as well. So keep checking in today. So what is the reaction that's happening here, Simon?
It's just growing bit by bit.
Yeah. From a chemical standpoint, this is actually hydrogen peroxide, and the yeast extracts the oxygen from that, which leaves us with water and oxygen. Ooh, Toby, maybe my special solution isn't strong enough. That could be too, because there's certainly something going on. So we're going to figure it out. There's all different variables that happen. Simon, we're still going to make sure that people do their challenge. What's the challenge for today?
Take a walk inside or outside and find as many examples of physical and chemical changes as you can. Post pictures of your list.
Yeah, post pictures or post your list of everything you find. So we want you to figure out where some physical and chemical reactions are around your house or around your neighborhood if you're able to head out for a walk. Simon, anything else?
Come on, sweetheart. These are the big babies.
Is that about it?
Go ahead. Come on, baby.
Yeah, there's something else.
What's that?
I need to go to the bathroom.
All right. And with that, we will
And
see you we will see you shortly on Instagram, and keep watching for our elephant toothpaste. We are going to figure this out. Thanks, everyone.